Fractured Confluences V1. And this webinar is primarily going to be with Houdini and with Assem. So I'll give an introduction. Assem is an architectural designer specializing in complex geometries and generative design. His work integrates advanced computational strategies to push the boundaries of architectural innovation. Actively engaged in collaborative projects and research, Assem continually expands his expertise and explores new design concepts. His approach seamlessly merges diverse workflows, driving the evolution of architectural practice and envisioning the future of design. So welcome, Assem, and before we hand it over, just want to say for everyone here, just remember that this is recorded and you will get access. You'll get an email to watch the recording after we're done with the live webinar, and Zoom processes it. And just to know that because it is recorded, keep in mind that not everyone learns at the same pace, and we want to give you as much content as possible. So if you feel the webinar is too fast or you can't keep up, feel free to just watch it, and then you can follow along more closely with the recording where you can pause and rewind this as much as you want. If you have any questions, you can ask them in the chat or with the Q&A button. If you want to use the chat, just remember to switch the chat to say everyone. I think by default, it will say like to hosts and panelists or anything like that. Make sure you switch it to say everyone. And yeah, so we'll hand it off to you now. That's all.
All right. Thank you, Michael. Yeah, I'm really proud for being one of design of his students, to be honest. So I would share my screen. Right. Okay. So today we have let's say we open support for procedure modeling, and as I'm an architect, how I really got inspired from computational design in general, and try to invest more in architecture, and somehow I plan let's say the advanced modeling tools, which is helped me a lot on experiment a lot in architecture. So our webinar talk about fractured complex. So it's a research which is I just want to ask you if I would close the camera and then so I can and then
yeah, I think it's okay.
Yeah. All right. The work is for our schedule today, since it's 5 hours, and we really want to cover everything in Houdini and how we're going to use it in architecture wise, because actually Houdini, it's very it's not that much easier software. So it's like it comes for many industry, let's say, and somehow we want to engage these powerful tools in architecture. So it gives really a big potential for somehow going through this. For our today schedule, we're gonna go through introduction to Houdini. That's the first thing. So we have 5 projects which we're gonna go in depth with 3 of them, and then we're gonna go fastly with 2 project ideas. So basically, the fracture, it's a design language I really kept developed during last year, and I would really emphasize how the potential of this language is. So what is procedure design? That's now the question. But actually, before moving to procedure design, let's go through some or different types of art, because actually artists, let's say, they use Houdini for not only architecture, but it's like for different kind of art language. So for example, let's talk about geometrical forms such you can plane, for example, here what we can find in the pictures: circles, squares, polygon, polyhedra, and these shapes defined by precise mathematical principles. So in design and architecture, they serve as a fundamental elements, providing a basic of creating complex patterns and special configuration. So this artist, Peter Craig, he's really famous with this kind of art, and going through generative design, which is that's a way that Houdini is very famous. So generative design is competition approach, use algorithms, iterative process, explore enormous design possibilities. So usually we define parameters, constraints, objects to guide these software tools to generate and refine some solution, help us to generate these forms. It is same, but it is another artist called Lee Craigs. So moving through a different kind of arts, it's a collegiate forms here what we can find from this picture for an artist called Peter Trakan. This texture refers to the composition of diverse geometrical. So organic shapes, what we can feel, combined with very surface qualities to create somehow visually rich and dynamic designs. So here we can found designs through simulation. So what we can do here, we usually what we found use computational methods to replicate real world behaviors. So allowing designers explore how material and structure perform under different conditions for better optimization. So what we're gonna do in our webinar, we trying using Houdini and these powerful procedure methods. So we somehow plan fragmented forms with details, textures using displacement map, noise function, simulation. Like it could be also perfect for architecture, digital arts, immersive environment. So our question, we're gonna back what is procedural. So procedural is a design approach, somehow focus on creating systems that this system generates outcomes based on rules, process, rather than the normal way of modeling. Like we use, for example, if you have an experience with Maya, 3D Max, we somehow use this manually way of working, which is here we have something. It looks similar a bit with Grasshopper, using algorithm simulation to produce flexible, adaptive, and reusable result. So the procedure is the most powerful thing that you can imagine. You can generate on multiple options from your design. How to ensure procedure? It's very, very important question, because actually once you work with Houdini, once you start to figure out the software, you're gonna imagine like maybe it looks hard a bit, because actually maybe you could attract a bit to try to modify something through the screen, but to make sure that this is procedural way of working, you have to focus on creating adaptable process rather than this kind of static object. And also you have to avoid fixed tools instructions or traditional model workflow like what we discussed, and let the system, which is something really, really powerful, to handle as much as possible. We saw somehow like this manual art direction, which should be reserved for necessary adjustment and ensure changes. Like somehow this way we have to say like the upstream distribute the downstream network. So if I'm gonna change something from the upper, like if I draw a box, for example, it shouldn't be effective. Like I'm not gonna break my my system because of that. Here is another examples for adaptability and variation. Like if you can focus on this picture, you're gonna find like I'm just moving the timeline, and this timeline, it helps me to generate multiple options and multiple way, even it's a change the attributes behavior. I'm going a bit let's say I really want to talk before going through Houdini, because I believe like we really must understand some definitions before going to the software. Houdini nodes, like it divides for subs, bobs, and bobs. It's somehow the most important nodes. It's called surface operators, which fundamental aspect in Houdini. It's somehow like focused on, let's say, 3D modeling, geometrical manipulation, seem like extrude, bevel, it's like all of that. So for instance, like what we have here, and also let's say it's called the basic geometry creation. Same like what we found here. For example, we have revolve, loft, for each, and the sweep. So moving from surface operator to dynamic operator, this is the second way of Houdini. Somehow these nodes, it help you to simulate, it seems like fire, smoke, let's say, once we make something dynamic or close, which we're gonna try today. And the last one is VOBs. So VOBs is provide visual interface for writing code. So it seemed like what we use in Grasshopper, for example. Houdini gave us a way, like instead just writing codes. If you are not good with codes, you can really go through VOBs. It seems like the same, but it's visual way, which is makes the life easier for us. Moving from Houdini nodes through noise and randomness. So once I really want to discuss what is the difference between, because actually many people got confused between these two words. So randomness is something usually purely chaotic. It's really lacking the way of scale, orientation, and produce unpredictable results. It's like in contrast for sure noise, because actually noise has both scale and orientation and displaying patterns and structure. So when deciding between these two, you have to consider the purpose and the context of the variation. So for example, I usually choose the option that offers the most visually pleasing results for your, for example, your specific goals, like noise is, because actually noise is often preferred when you need control, pattern, and variation, while randomness is suitable for truly uncreatable elements. So that's the point that we can really understand these 2 points. And here, examples for what is the noise can do. And also, if we go, if we see the second picture down, we're gonna have what VOBs mean. So VOBs, as we said, it's a visual way of coding that, for example, I can do some noise here, which is a noise. I have some attributes, so I play with position, and from this position, I go to play to add some noise and play with density. Noise function, it's a very important topic because it provides a wide variety of outputs. This picture, it really represents what is going, because actually different ranges, different characteristics. These functions can create diverse effects from natural texture to complex procedural patterns. Typically, like noise control includes scales, offset, complexity, density, for example, and allows for adjustment. Here, example for kernel noise. Here is also some example like noise distortion. What we see, like we have these wave pops. But as we said, we somehow control this noise. We have different kind of noise. We have like noise expression, as we can use the codes. And what we last slide, we see how we can use this way, the VOPs, which is the visual wave operator. So noise types, we have here some, we have Voronoi noise, we have Worley noise, we have kernel noise, which is all of them. It's like I can really generate many types of noise. And also they give us additional feature with something called unified noise, which is just one node that I can have all of these kind of noise in just one node. So going through the random function, which is Houdini generate random value between 0 and 1. We have to know like Houdini, it's like the random value, like, and also I think that in many software as well, random should be between 0 and 1, which is you somehow algorithms to produce values that appears random and ensure repeatedly by generating constant random value for same seed. That's how we see like between 0 and 1, not truly random, generate constant random value. Here an example, how it's going to be randoms based on color. And moving through attributes and variable, it's something also how Houdini work. So Houdini, if you understand the logic of attributes, you're gonna really understand how to handle the software. So if you, for example, imagine a box you have and or any other object. So usually this object has color, and let's say has also position, has also let's say if has some distortion, has normal, which is a surface normal, and all of these features, it's called attributes. That's a way. So that's how Houdini handles. So Houdini is not a normal way of modeling. Like you really have to understand, like if you have box, like what these box have, because actually you somehow manipulate with these attributes. So as we said, like attributes store data on the geometry and processed until modified or deleted. You have many things from attribute, like it's represent, like for example, add P for position, add CD for color. And also you have something called variable, which is it's a temporary data containers within like code blocks somehow. And they it's like it's truly limited to the block. You can I will support you with a lot of documents, a lot of blogs, so you can go in depth and understand like what attribute means, because actually it needs a lot of time somehow to understand the logic behind and then to get more familiar with the screen. So for example, here copy attributes, I got very intense practice with that. Also I will support you with Houdini documents so you can read what is going there. And that's an example I'm gonna give you for let's say I will not do it today, but I will share you the file and I will try to discuss what is going on so you can get more familiar with this logic. Here is Pop's transformation. Like we somehow we may know that it could be transformed, it could be scaled, could be have this kind of rotation using visual wave coding. So moving from this to volume, I would share the presentation because actually I really want you to go more in depth. That's how Houdini be covered. So volumes, it's a 3D grid that stored data like density, temperature, distance, and used for simulation and effects such as smoke, fire, fog volume. So while a volume defines the surface using sign distance, Houdini often use the PDB formats for efficient storage and competition. So here we can see the picture that is displayed somehow the volumes, and this we have two types of volume. We have sign distant field. It's like it's a voxel gray store somehow distant to the surface with sign value indicating whether points inside or outside the volume. And this surface size is something very important. It should be represented by 0. And the fog volume somehow, if we think about that, we're going to find it store data like density in a voxel grid in simulation. We're going to have a practice in that for sure. And during today's webinar. So this multiple fog volume campaign to represent complex effect like smoke for like heat, like temperature. All of that is example for volume STF and how we usually play with that with normal. I would also really strongly recommend to go more in coding. I don't know how much you experience with coding, but you don't have to really be good with it. I mean, like, you have to understand what is going on. So usually I try to use ChatGPT, to be honest. I know how I code, but I use ChatGPT to somehow give me more variation, make my life easier. Also, if you are not familiar with coding, you have to just catch where is the basic of that. So what VX actually means, it's a vector expression language. So VX is a vector expression language. Like coding language in Houdini allows you to tell Houdini what exactly should do. Same like for sure other I feel like it's close a bit for C#, let's say, or if you are familiar with Unity, you can really have the same language, which is Python. Like if you know any coding language, you're gonna really get familiar with that. So I'm asking here a very, very important question: what is a program? So I'm gonna respond to that question during what I'm doing in Houdini. So, like when we write a code in attribute triangle, we are essentially breaking down complex process in smaller. So when we could usually, like, we have these steps, which is we somehow divide it, and then after this, we're gonna combine all of that. So this allows you somehow to control the behavior. You can manipulate with your geometry. And another way of how we write code. So for sure, we do it line by line and usually ended by semicolon. So I would really have this important introduction about VEX, because actually once we go inside Houdini, we're going to have more way of doing that. So variable, it's store data. It's like declaring a variable, define type, and assign geometry. So here also we can go common type of variable, including integer, which is stores a whole number, and floating points. That's what we discussed about attribute as well. And that's what and here is something called function. Conditions like if else, for each, while loops. Like I really prefer to go more in that. Like it's the one, like the webinar cannot cover everything, but I make structure which is we can understand the basics, let's say, and I will give you the key to go more in depth, and you can develop yourself more and more. And also we're going to share many files, many books for reading, like how you get familiar. So we're going to hear, like for our webinar, we're going to have 5 projects, which is somehow represent what we're going to do. It's all the same logic, which is based on fragmented or fractured design, let's say. And somehow we're going more beyond about that. You can use it for sure. It's initial experiment I've done. I didn't include it for a specific project because somehow I was really investing with the language more than the application of that. I would say I really love how I really love ecology once you link it with architecture, but it also comes from competition design field, which is I found Houdini is something great to convert your ideas, to convert your let's say what we can imagine, what we can see in natural system, and you can convert it here. My webinar like explores the integration of fracture design principle. So we're gonna demonstrate how architecture fracture can be dynamically enhanced through fluid, particle, and volume simulation, enabling the creation of innovative and interaction design. I would go afterwards for just one thing, like I would have this fracture stuff using Houdini and AI, which is I would imagine what is can be beyond that. We're gonna move now to Houdini, so we can have a short, let's say, we're gonna have stop sharing. Let's share our Houdini program. This chart, we're gonna start like introduce the software. Okay, so once you open Houdini, you're gonna find that's what you're gonna find the screen, something like this. So I don't, to be honest, I'm not feel comfortable with this interface. So don't be scared with Houdini because actually you're gonna have a lot of screens and all of that. But again, if you're familiar with Rhino, once you open Grasshopper, you're gonna have this two splitted screen. So it's not something really probably, but the point like Houdini really needs a lot of practice so you can get familiar with it. So we have here this screen, which is we have on the left viewport, same like other softwares. And also we have the networks, and we have here parameter editor. We have some notes, which is you can hear, for example, I would really print box, for example, and I can, if I press Alt and middle click, I can go and somehow rotate form, something like this. But here I'm working with the viewport, which is we don't try to avoid it as much as we can. So let's say I really want to structure it a bit because actually I don't feel like more comfortable with this. So here we're gonna have bottom, which is we can bring it up a bit like that. And once we create a box, if we press I, we're gonna dive inside, or we can have double click. So again, we have here this button, which is camera. We can somehow just rotate without affecting the geometry in the view bar. And from here, for example, we have some channel, you have material, object. We're working now in object channel. So Houdini is something like layering, like you have object, you can go more in depth to work through this object, and then you have your nodes. So if I select, I'm gonna, for example, if I right click, I'm gonna have this tab menu. If I right box, for example, I'm gonna have the same what I draw here and drag it. So I want to see, after I made it up, I really want to see my parameter editor here. So if I press P, I'm gonna have my parameter editor. For example, I can control the size like this. I can center it somehow, I can move it, I can rotate it. And if I press G, I'm gonna zoom it in. So I would go and see the setting. So the setting comes from D, like just pressing D, because I want to somehow change the background. So you have here display options, which is, I prefer usually getting through dark. You can set it as default for sure. And then I really want to hide the gray. So here you have some options, which is somehow you can make the camera is not be affected like this. You can show gray. You can here show your points. You can show number of points and the normal, like for example, what's the point number here? And you can also ignore it. If you press here, you're gonna find also a lot of way to visualize your object. So for example, if you want to see the edges, if you want to see it like empty here. So it's about your way of how you want to understand what is going on. So moving from this, I would really I would really have box, for example, let's say 4 by 4 by 4. And if I press here, I could have G, so I can rescale it again. I would really share shared file. It's like, okay, I would go before that to see what we have from which material we have for doing with Houdini. Like I'm going to stop sharing. I'm going to share my right. So I would share this link now. So we can have this is how I organize the workshop. So this is a material we have. So that's our files, which is represented by different file projects. I also have some Houdini foundation, which is a file from Houdini website. Also, you're gonna find here some notes that it's really could be great practice for what we have. I guess you're gonna find like a practice on attributes and variable. It's like once you open Houdini file, you're gonna have some practice for transformation, for example, which is I really prefer to have to look for that. Here is the presentation already added, and also we have some resource. I add two boxes, which is the first box, this one, talk about the algorithm and beauty. So let's it would be very, very interesting to try to read about that. So that's the first one. It somehow discuss the algorithm beauty in the planet. It's like I feel like it has a big link. Like I think this box it really improved me a lot to understand the logic of Houdini. And also it's another book which is called Flames. This one, it's like the fracture of flames. It's somehow going through L system, let's say, and a lot of interesting things. Like really, you can go more in depth with that, and then somehow it gives you a lot of information to use it in your also it talk a bit about coding, about geometrical manipulation, which is a lot of interesting things going on. So let's say here that's fine. I'm going to share. I would move again to Houdini. Let me share the link now. Here, copy. Okay. All right, I will continue to check. I already post now the Google Drive, so you can download, and also we can go more step by step. It's like it's not necessary to open the file now, but let's go through what we have, what we are doing. So for now, we draw a box. We somehow gonna negotiate the first approach of fracture. So we draw a box, but it's not for me. So for now, let's have another box if I want to draw like box. So right click and box. And then I would say, let's do this one's 5. This one is 5 here. So it's 5. And then somehow I would really, I can control the rotation, I can control whatever I want from here. So that's a way of how we work with it. So let's first thing, let's have something called add. So what add do, now we're gonna create a new point. So we need to have some points. So let's create new points by add. So I have here now 1 point. If I press G, I'm gonna see my points. And this is a number of points, so that's what I only have. And then I would say from this point, I wanna have more. So I wanna have multiple copies points. Let's say to animate the whole arrangement, so we can say like point duplicate, point triplicate. All right. So this is the output. I'm gonna plug it here. Okay, so what I'm doing now, it's like from this point, I move more. It's like I replicate multiple points, which is, I believe, like I need only 4. So now I have these 4. And if I go here for the shape, somehow this one is stretching a bit. Okay, which is if I go here for the shape, for example, I would really, I can move this one. Like if I can move the center, I can play with the center. I can play with the size like this. I can also uniform the scale, like I have multiple options with playing the shape here. I can also add some noise, which is if I want to add some noise, like it can help me instead playing with that literally. So after open replicate, let's try something. Let's go and have this kind of discussion between attribute triangle, which is vex, what we talk about, and what is Forbes, which is somehow we're gonna use point Forbes. So I would say here, if we just press AW, I'm gonna have like first letter from first word and first letter from second word. It's much easier usually. So let's say here AW, and let's plug it like this. And as we said, I really want to create some noise. So usually attribute triangle to write code inside Houdini, it somehow gives us a very unique way of conversation. So I would have here, for example, like this black screen. If I say Alt E, I'm gonna make it bigger so I can see exactly what I'm writing. The point here, I wanna add some noise. So I would write at normal, because actually the normal usually play, that's the way how I play with noise, and it's very equal. kernel noise. It's this type of noise, which is we already discussed before. And let's add here open brackets so we can see what add. We can have here add position, and then we can multiply it with channel vector for the frequency. So we need to write here frequency. And then we can multiply it with another channel. This one should be not capital here. It's like C. Okay, another channel which is called offset. All right, and then I'm going to end my code. So what I've done here, I just create two channels, which is channel called frequency and channel called offset. So here I'm playing with noise. So usually to play with noise, you need to have normal. That's the point. So that's how you play with noise. So if I say accept, it's gonna move the code and close. And if I press here, I'm gonna have like, let me Alt E. Okay, like let's hear Alt E because you have some, okay, like, okay. If we have here, like we have this, Victor, if I have here, let's discuss what is going. So the normal, somehow I played with the noise to manipulate that. And afterwards, I create two channel, which is frequency and offset. So apply, accept, and let's press here. And then I have these two channels, which is manipulate my geometry. So I would say here, for example, say two, I just say here, I would say two to like it depends about which thing I need. And also I can say I can play also with offset. All right. And then let's press Shift S because actually it looks a bit confusing. So after that, let's have a node called attribute player. It somehow it gives us average like color position, and we somehow we want to create more blended or softness effect. So that's a way of, so let's say here attribute layer. Right. And I want that affect my normal attribute. So I will press here N. So now I have this box and I want to use sub node, which is if I make here, if I put here count points. Sorry, count points. Right. I want to plug that one here and this one there, and let's have that. Let's see what is going. Okay. So what I've done usually, like now I have this point and I have this box, and then what I made here, I just set some of I just made some of, let's say, some operation, like I just copied this box to this point. So what we're really looking for, we want to have somehow of intersection between this point and another box, which is if I draw here box, and let's say this box could be 4 by 4 by 4. And if once I select the nodes like this, if I want to press and show the nodes, I'm gonna press first icon. If I made like this, I'm gonna just see it as wires, for example. Like if I just press the second option, I'm gonna see what is happening with the fragmentation, which is somehow, I believe it's very, very important. And also, if we like to show what is the process going for the scale here, we have really nice knowledge, which is if we behave with uniform scale, like you can control which exactly scale you need. For example, okay, I would be satisfied about that. And then we have something called poly and fracture, which is this is the most important node of the idea of fracturing. So if I press that one, and then I add my node here, I'm gonna have the lines somehow affected with the way of working. Like, so now I have my fracture. It's affected, but the point, like, I want the fracture affected by this kind of colors, because actually now you can really control what is going on. Because if we just like use something like Poisson fracture here, Voronoi fracture, you have another type of fracture. So if we use Voronoi fracture, we're going to have a fracture which seems like Voronoi in a bit, but it's not affected with what is happening here. Like, I would really say it's like the best way for the beginning to be straightforward with what we have. So I would really satisfy about what is going here. And then if I turn this icon, I'm going to see more visually what is happening. All right. So let's go through to just try to figure out what's happening here, excluded view. So these nodes usually show us what's happening through this kind of nodes. I would really see what I would really close this views now. Like if I have one, I would really hide it from here. And for this one, okay, let's close it. And now that's what is going. For sure, I have mini small fracture pieces, which is I don't need. So here, that's a way. I believe like if many of us are doing this for architecture, it's a great way to assemble. Like I'm usually doing this models somehow, so I really want to have this kind of assembled idea. So it's fractured and then excluded view, and then it gives us opportunity to see where is your pieces and then how it's going to be integrated, and then you can go more forward with that. All right, so that's a fracture basic. And then I would really go with the idea of how I use the timeline. So we didn't introduce something here with the timeline. It's basically, I consider it the heart of Houdini, because actually you somehow wanna, it like, this is the way how you get variation. So you design by using attributes, and for these attributes, you somehow going to change the timeline, and then from this timeline, you're gonna have a lot of variation. So how we're gonna do it? So let's go here with point duplicate, like this point. I really find something interesting if we somehow try to move this point in a way, let's say, and then we're gonna have this this movement. So from here, for example, from the shape here, if I imagine like let's say I just move it from 0. If I just put my frame like here in the point, like 0, and just shift enter, or sorry, like 0, just control enter, or let's press or click, right click, and then keyframe, set keyframe. So what I've done, I made keyframe in 0. So right click, and then you're gonna find here keyframes, and then set keyframes. And let's imagine like, okay, I'm gonna move here until I would say maybe 100, or let's have 180. So if I come here and I write, I just want to see the timeline for 180, something like this. So the timeline for me ended at this time, at this point. So if I came here at the end, and then I just move it somehow for 0.2, or let's say, yeah, it's like 0.02, or let's make it more clear, like 0.2, and then I'm going to select keyframes, set keyframe. Let's see what's happening. So I think like it's something went wrong. So let's say here 2.1, we'll have 0.1. See keyframe, and then 0.02 key at this time, this point here, which is set keyframe. All right, at a triangle. I don't know, but I don't know. Somehow it's hidden with a way. So let's go through. Right. This is a good rule. I would really love to go through here, like point replicate again, and then let's see what's happening. Keyframe. Frame. All right. Some to be triangle. Okay. Delete it. So it's split view. Let's see. Let's have here some called the small bar to, and I think like it's really confusing what is going on. So press G. Right. I think it's going. I would really here go more on okay, so we have something here which is called SideFX Lab. It's really nice to download it. I think if you install Houdini for first time, you will not find it. So SideFX Lab, and then you can update from here, and then you can start launch, and then you can update yours. So it gives you this note, which is somehow, let's make the story short, because actually I would really go and somehow just try to ignore the normal way of delete. How you delete, if I want to delete something, how I delete it here in Houdini. So if I say here plus, for example, and then I press, I can delete many pieces, which is now I'm trying to work with this field. So I would have here, press enter. So I have to turn this on, and then from this enter, and then I can select what I need, and then I can have it, and then I'm going to have it here, which is I don't prefer at all to have this kind of way, because actually once you move your procedural growth, you're going to find it's like your process is going down. So let's go with a node called connectivity. We're going to use it a lot because somehow it's connect a component in a geometry. Like if you have smaller pieces and then somehow you needed to go to connect it with integer way, like that's how it's going. So connectivity, it's assigned unique integer to each connected components in the geometry we have. So I would move here and make it primitive. Because actually, if we ignore this node, we're gonna have like our fracture is gonna be destroyed. Let's have here some node called measure. So what measure do? So I wanna basically just create variety of measure for my geometry. So you can here like if you see here what we can do, we can have area, we can measure area, we can measure volume, we can measure curvature. So I would say here, I need to measure volume, which is, if I can, I really want to get that by pieces, not by not by elements. So if I say here by pieces, I'm gonna get, so now what I have 21 pieces in total. So I would really ignore what is going here, and then I would say press camera, press G. And then let's go for the way of how we can do lost with a procedural way. So I would say we need to select like the idea we need to have group, which this group can select the smaller pieces and then plus it. So I would do formula, let's say, so we can somehow ignore the pieces without plusing manually. So I cannot break my I cannot break my process, let's say. So there is a node for grouping called group expression. Okay, I would say here group expression, or okay, group this node, which is somehow the idea that I want to do two channels and I want to rename it with the same name so that I can have two channel like minimum and maximum, then I can use both. So if I add like group expression channel, like I'm gonna add two, I'm gonna rename them with the same name, like let's rename them with selection. I would take that, copy and paste, and put it here, group two. So I would write expression, which is I have this measure for volume. Now I measure the volume, so I have 21 pieces, and I wanna tell him like the smaller volumes, it comes to channel like I want to make a channel for these volumes, which is small pieces, and then I just select it, and then I would have another channel which is for the bigger pieces. So let's say here I would say add volume. C chat, which is channel, and then I would name it minimum, MIN, like minimum channel. All right, Control C. So that's my code now, and then let's have it Control V. And then I wanna just have here, I wanna choose union and existing. I wanna integrate that with the channel, and then let's press this icon here, which is can bring our channel. So I have to change that through smaller. Yeah. Next. All right. So now I have these two channels. Okay. if I go here and then I start somehow see what I have. So you can find I'm selecting the pieces, which is it's smaller and on the based on the volume. Okay, like that's how it's going. And then I'm here, I can control also the bigger, which is I don't need to select a lot of that. I just want to get rid from something that I don't believe it's going to be helpful for me. And then I'm going to have plus. And I would say here, I'm going to choose selection, which is this my group. So once I say plus, I really have I have the option, which is I can select the group, which is here. It's going to be like this. So the point, like, why we ignore plus node from the beginning? Because absolutely, if I just go here and then I started somehow with selecting everything like this, it's going to be a very weird way of selecting. So same like what I'm doing on at normal modeling techniques. And then if I press enter, then okay, I succeed to select. But once I move, I'm going to have distortion for my elements, because actually now it's like I have this number of surface, which is this number of primitives, which is for sure it's changing by time. So now I have like this kind of distortion habits, which is not good. And now it's like I broke my system, which is this something is not preferred. So that's why we usually use this kind of way, which is we put code. So we somehow measure the volume, and then after measuring the volume, we start to have grouping for these volumes, and then we delete it. So that's the difference. So now we can go, and then it comes without any let's say it comes without any distortion. I would go, I'm happy with this result. And then I would say here null, which is this node in Houdini. It means nothing actually. It's just a milestone for what we are doing. So I would say here this is a base fragmentation. All right. Okay, so for me, I would really use this like as a base for everything's coming. So now I have what is happening here, which is I believe like it's generate multiple options, and then I would really go more in on that. So let's get this as line. So I have a node here called convert line. This node. So I'm gonna get it as lines. And then I would resample that. What resample node do is somehow distribute points along curves. So for example, now we have only these points, which is I mentioned here's a number of points. I want to see what is going on. And if we press resample, now we get mini, which is I need that for more manipulation after after what is happening. So I would say there is an out called polyframe. So polyframe, it's changed the normal somehow. So this node generate normals and tangents for polygon geometry. So I would see here, for example, we have this normal, and once we go there, so this is the normal we have, and as we said, that's how we have with Houdini. So if we press I, we're gonna figure out what is happening. So actually, that's how our attribute is. So for example, until now, for this node, we have attribute called position. If we press here, we're going to see it's a position attribute. We have primitive attribute, which is class and name, and you have volumes, and you have also vertex attribute, which is related to normal. And also how we can go more in depth with that. So you have here geometry spreadsheet here. So in this sheet, you can figure out which attributes you have. So for example, your geometries until now, it moves on position X, Y, and Z with this value. And also you have here your points, because actually Houdini's each point, it has 4 vertices, which is something like, if you have 1 point, like it's surrounded by 4 points, which is somehow going through X and Y and Z. Like that's how is a point move. And you have in this video, you have also primitives, which would somehow show us what attributes here we have in our primitives, and we have nothing in our details. But also, it's very important to get familiar with that, because actually that means how you absolutely have a full understanding of what is going on in the software. I would say here polyframe. I don't wanna. I would really go more with that, and then there is a node called smooth. Okay, so why I'm using smooth? Because actually I would really give an option that I would play with the smoothness of the line, but I would keep it later. Like let's put it here, and then let's have something called bound. Let's have bound. So what bound do? It's like make a boundary pods. Like that's what it is. So it's somehow make our geometry inside bounding, because actually I'm looking forward afterwards to convert this to convert somehow the bound through volumes, and then I'm going to use a velocity from this curve to generate trails. So let's see here. I would say, let's see VDP component. Okay, so that's how we use this box related stuff. That's how VDB work. I would really change and change the box size a bit, so we can do it 0.025. So it's changed, which means that the resolution bit, I don't need distance from VDB, so I would go through density. So now I got my box, and then I would say there is very good node, like this is one of my favorite actually, called volume. I'm not sure if that you need to have SideFX lab to get but also like just make sure you have like let's say Houdini version you have, it's more than 20, I think, because actually if you have like I don't know, Houdini 18 or something, you will not have it. So let's plug this one here, and see what is going. All right. So now I play with the density a bit. So let's change that one, the voxel size to 0 to 5. Okay. And then for the bounds, I would Oh, okay. So I think like let's have here I can play with the channel, but I would say let's change it manually. So if I just press 0.9 here, it's loading pending 0.9. Okay, I think like I can. Okay, so let's press here copy parameters. It's something I believe it could be interesting. Like you have here, if you wanna get if you wanna somehow make the same what happens here, it's like we wanna write nine for example copy parameter, and we're gonna have it here, for example, paste parameter. So I would press here, for example, 0.9, 0.9, and then let's copy parameter. Okay, and then let's here paste relative reference. All right, I'm sorry. Like, because actually somehow it's been like we can delete the channel, which is here. Also, we can delete your channel, and then if I press 0 here again, you can again paste relative reference. So what I've done, I only paste the channel. So paste relative reference again. So you can here copy channel. That's the way we can do it. Copy parameters. Okay. Paste relative reference. I think it's clear, like, yeah, then for sure we can do it for all. Paste relative reference. Paste relative reference. Okay. So I create a volume now. It's like it somehow the painting looks much more effective. Okay, so I just want to make sure that like all my steps are going to be fine. Okay, and then I go through velocity from curve to get something here. I think like I have just something wrong here, and then that's how it looks. My point that once you change the timeline, it's going to be affected on the volume that happens. So if I examine, like if I come here, like the volume is going to give you another shape. Like also there, like that's the way how it works. Like now we achieve a procedural way of conversation, so we can have like this kind of variation. So I want to scatter this point. Really go here for, I want to blend it smooth, because actually once I have this scatter point, I would create volume trail. So let us scatter. So what does scatter do? So it somehow create points over the surface of the geometry, and we generate specified number of points, and we somehow let's imagine we set density value to control the spread, and with this way we allow to add points to the polygon or the volume or the surface. So if we come here and then now we scatter it somehow, so now we create some volume, and then let's have like 5,000 maybe. I think it could be fine. Yeah, I think that value could be fine. So now I get I scattered a bit. I scattered some points randomly, not like the way I've done here with resample something absolutely different, because actually now if we go here, we're gonna find it's more random, and that's what we want to achieve. And then if I say here volume trail, so okay, I would contact that here on the first node, and then have that, and then I'm gonna get my trail. So so this is a trail I've got. So it's basically the idea that scattering points randomly and have this velocity from curve here, which is now what I'm doing, I would have this trail based on what is shown here. So you can press I if you have some information about the node, but that's how it's going. And then let's go more forward with, so let's call this step as trail. So if I press all of that here, and then there is icon here, it makes group. It's like it makes group here, and then I can somehow write what I have. So if I say trail, that's the step I have, and then I can get like that. It's a way of organization. Also, if I press this icon here, it's going to show some colors, and I'm going to have something like this. So let's organize ourselves a bit. Let's make group here. Let's press black. I really love to do it black because actually you can see even more clear your node. I would say also there's another step here, and I really want to say here some node. I'm going to say here node. And let's here call it, this is my lines. So let's call that. All right. Okay. There is a way to I would really resample it again. I wanna add some points to my to this form. So let's resample. Okay. Okay, that's fine. Let's go through VDB. I believe like now it looks interesting for me, because actually once I go through merge, if I want to show fastly what I've done, if I merge it somehow, what I have here, and also I would say this box is there to see the relation of the trails, how it's going. So now this is my trails. It's basically comes through or driven by the fragmentations, which is something very important, because actually I do want to let's say just make more distortion for the cube, because at the end I would imagine these boxes as my habitat, or uh, or let's say like this consider one language, and then that's how I'm gonna blend them together. All right, I will go to resample again, and then let's go through polling, which is BDB. I think we had the intro. We talk a bit about BDB. So BDB from Bartka. All right, it's too long, and then I just need to we just make the voxel size it's a bit smaller. So if I have the 0.5, So I convert my trail to it needs some time just to start. Okay, it needs just some time for let's start to calculate. Like I think I should make it even more, not that much. Because actually once you talk about VDB, I think you should have very nice computer to have more resolution of your service, let's say. So I would say here, I just make like I would say 0.2. So this a box size, and I for here, I would say for the point radius scale, I'm going to scale it a bit. Let's say here, point 0.00. I think like okay, 5 that could be fine. And let's see what is going. Okay, entries scale. I think that's okay. And then I would say here 0.005. All right. If I press G to see what is going here. Okay, so basically I create this volumetric thing, which is somehow, I believe here, the point is not connected, which is, I have a problem with the sample here now. So I would say, if I go down, I would make the length of how the point is going to be connected, 0.01. So now it's fixed, and it have more elegant way of talking. And then I would go for reshape. So VDB reshape. Usually it's like, once I have here VDB, I really love these nodes because actually it reminds me how you can freedom for doing any geometry you want. And also afterwards, you can go more organized. So you don't have to think about, once we're working with Maya, for example, we have to be elegant a bit with where is our points, like the normal way of mesh geometry. Here, like it seems like ZBrush, once you have this kind of sculpture, and then you start to enhance the polygon, it's really a great way to have this kind of conversation with the tool. So I would say here another component called VDB reshape. It's like, I think it's from the name, it's reshaped the geometry a bit, so it give us let's say a scale. For sure I can reshape it more, but I think it's one could be enough. G. By the way, like if I use it again, like I think that's totally fine. Like you can use it again, you can have it too, like as whatever you want. It seems like the most important thing is the logic itself, and then there's something called, let's smooth it a bit. So there is a node called VDB smooth SDF. Here, right? So we smooth it a bit, and then we're gonna convert it to mesh. So now, until now, it's not a mesh. Actually, it's like voxelated shape somehow, which is now we're gonna have it as mesh. So let's convert VDB. And then we can choose here polygon. All right, so now we have our shape, which is, I think it's good. So let's have, I would go with materiality, but I don't think it's time. Like, let's here merge these together. It's like, let's merge these two steps, which is, I believe it's going to be fine. So that's how it's looking. So I would say I don't need this because actually I want to convert it to VDB as well, because I believe this kind of smoothness looks a bit cool. So let's have, or we can copy and paste the node, by the way. So VDB from polygon, we can have all of that. So we can say VDB. Let's use a box, like which is, yeah, so, okay. Let's make the voxel size 101. I think it looks fine. And then reshape a bit. And we can, what we can do here, if we can make the story short, we can copy and paste what we have, Control C and Control V. And then what we can do, we can plug that here, and then we can get our shape. So for me, I really love the way of how this model is going, because actually straight edges is not give that it's not give that beauty of the form, because actually nothing is straight and natural for sure. So if I merge them together, I'm gonna get my my first wave conversation. So this is my first shape now. For sure, I can make it merge it to one shape, but the point here, if I have material, I would use it as two type of materials, which is it's based on your eye, and also it's based on what you want to do from this experiment. So I use a fragment, and then somehow I generate a way of doing this shape. So what if we change a bit on the timeline? And that's a point here. Let's imagine, like, I don't like this result, for example. What if I just moved, for example, here with the timeline? I'm gonna generate another shape, basically, because actually the volume is a change, which is the timeline is changed, and then I'm gonna have another conversation of my form. Yeah, and that's a point here. All right. I think before going through the trails, and then maybe we can, before even moving through this kind of trails, I would really love to link that with the site somehow. I don't know if we can Mike, can we take what do you think if we take a 10-minute break or something? Mike, hello? Hello. Okay. Um, okay, cool. Yeah. Thank you. Thank you, Robert. So we can take 10-minute break, and then we can come back. Okay, see you. See you
Yeah.
soon. Yeah, thank you. Okay, 10-minute break, and then we can go back. All right. Okay, it's back. I would really have afterwards. What about the ground? What is happening there? So I think in this in the first project, somehow this is the hardest because actually we somehow introduce everything through Houdini. I think we talk about something called DOB network, dynamic operator. We're gonna have something briefly about what is going there. So it's let's say it's a way which is somehow you create and simulate particle based on effect. It's particle operator, that's how it's called. So how we get it, like let's say pop, it's a popnet, or like if we just press right, popnet, pop network, right. So you can see you really maybe you can find the color of my component. It's a bit different because actually I'm somehow try to change the color to make it let's say comfortable for me. Like this component is something very thing. So if I press that and then click right and just choose the color which is here, and then I'm gonna have another color of my component, which is makes a life, let's say it makes my life easier. Okay, so I would take the smooth lines here, and then I'm gonna plug it here, and then if I press turn it on, okay, so it's like the simulation start, but for sure what I want to need, like now it's not affecting anything. Now that's how it looks. If I change the timeline here, it's like it's not affecting anything. Okay, so let's press I to dive a bit inside and see what is going. So usually dynamic operator, somehow I'm getting the resource object, which is this one, which is plugged already there. Here, this is considered the input is a resource object. And I'm doing some component, which is I could add force and many things. And afterwards, I could somehow get the result, which is it's called the recipe, the brain, which is the solver here. And then I would add some forces, which is you can add, like, for example, like it's many forces, like if you it can affect about the particle simulation. So if we come through the as a conclusion, what its particle actually be affected on parts, and that's what we are doing here for playing with that. All right, so let's go in depth and see what is happening. I would say here I'm gonna add fob, which is, again, we were talking about fobs, which is a visual wave coding. So we're gonna use it here, but this time inside bobnet. So if I dive inside, I'm gonna see something else. So what I'm seeing here, it's actually, reminds me with the same wave grasshopper, let's say. What I usually do, I have some attributes, which is ready, position, vector, force, live age, because it's here. We talk about points, bobnet. It's like it's not. And I would say it's somehow I have input, which is this attribute, and then it's going to affect it by the output, which is here, and I can add something else in the middle. All right, so let's say here I'm gonna have some parameters, and then I will write it, and then we can go more in depth to understand what is going on. Okay, so parameter, rename it. Let's here rename it direction. Let's rename it like this. It's like to have this direction. So once I press right, I'm gonna have another menu here, which is inside props. It's same again like crossover, which like it's the same way of coding, but instead coding and do it visually. So let's have here vector to float. I want my position to be translated to X and Y and Z, because actually I want to use only Y direction to be added. So I would say here, add this parameter and also the Y direction. So I can really consider it as laying option after. So I would say here, bring me some noises. Let's say card noise. Okay. I'm gonna plug position to position. I think like it's bare noise could be fine, like this type of noise. So I would also say vector to float, which I can see Ctrl C, Ctrl V. And then I would translate it again, float to vector. You would a bit for sure for the start, you're gonna have it a bit hard to understand what is happening here. It's your first time in Houdini, but once you get familiar with it, you're gonna really love the way how it's going. And also the most good thing that we have this webinar recorded, so you can watch it time by time, and then more practice. It's gonna bring more full understanding for the software. I wanna hear and normalize. Okay, I would say normalize and then round to integer. I wanna round that to integer. So and plug it to vector. Let's see what's happening. It's like I wanna figure out what's happening. It's okay, it moved perfectly, but this is not the way I need. What we can do here, let's have something called promote. So if I say promote parameter, I really don't like the way of going up and down. So I can, here, for example, I can control my parameters from this direction or even this direction if I want to promote something. So let's promote all of that. Frequency, if we middle click, promote parameter. All of that, I think that's fine. All right. If I go one step back, let's see what's happening here. So I got all my parameters here. So I can really now control like this PubNet from outside. It's not necessary to go every time. So like let's put it here, 0.4, and the frequency, 0.4, and then 0.4. Right. I think that's fine. Like I would also choose if you see here the noise type, it's give us option to change which type of noise you need. It's like this noise, the ones who control like this kind of growth for the particle. So I think okay, let's try this one. Simplified noise. I would go and try again. So it means like turn what is here. I think it's still not what I need, but also because actually it's going up more. I really want to get rid from what is there. I can see what is happening, but also I wanna really make it more. I want something go up to have this kind of connection if I'm gonna aggregate my units, but also I would really happy to have it more down so it can be scattered to the ground and it can help to bring other units toward. Like it's considered as a connection layer, but we can add here, we can play also, we can let's say we can talk about the gravity, which is something very important. Okay, so if I go here with the source first input that is absolutely have a full control with everything happens here. Like if I just at the point I need only 200, so like let's say only 200. So the number of points is become more not that big. It's not shown, but I think it's also we're gonna control it with trail. So there's something here which is we need to somehow use a standard operating in the simulation. So it's that gives us a way of more controlling. So if we have here something called stop geo. Okay, well, I don't need to change anything here. And then I would go for the force. So let's have, let's call vortex forces. Okay, let's see. All right. I would have this one here, have this one there. Okay, I think that's fine. Let's go here and see what is going on. I would be really happy if I just make some lines it's going through, like let's press G and it's here. This I really want to show some lines here. Yeah, I think like that's what I have. And to be more better visualized, let's add trail. And it's so trail, it's moving the particle or the point, and somehow it's create geometry or particle over time. It's like so it's if you see even from the icon somehow doing this and it's connected with a way. So I would choose here connected as polygon, and I really need more trail length. So let's say here 240, for example. All right, 240. Okay, that's how it looks. I think it's pretty cool because actually, if even you don't need these lines, you can control it. But I think it's somehow these lines, it gives you an extension for what is even after. That's the point of it. So we can resemble this a bit. So let's resemble. Right. So resemble the line. Let's see what is going. Okay. I think it's fine. Like I would say it's okay. It's one. The length, I think it's. I don't think we need to have this kind of like maximize the length anymore, because actually I think that's how it looks, because I'm pretty satisfied about the number of points I have. But why I'm doing this, because actually I want to have here the curve view attribute. So I want to control materiality maybe after, but I feel like it could be very sad. Let's resample again. Control C, Control V. Yes, we can make it more more bigger actually. Yeah, because actually I want to convert to VDB. It's the same what we've done here. Like it's the same way. Like once we have a scatter, for example, if we go back, we have scatter, and then we have volume trail, and then we somehow resemble it in a way that we need it to be connected. So adding points, it means like once I have here VDB from particle, it's going to give me the same techniques, which is what can do. I can really copy and paste this, Control C, Control V, and I can plug it in. And let's see what's happening. It's the same way. It's like, okay, VDP. I'm sure I'm trying to make my network bigger because actually this is the most interesting thing for me. And I want to see the network, and then the screen is not necessary to be that much big. You know, I think one view could be enough even. And let's merge all of them. So here I convert VDB. So this is my second. Let's say this is my second sheet. Okay. This is my second sheet. But I think we miss here something because actually I would say if I reshape it a bit, let's here reshape. I would really love to smooth it more because actually this kind of straightforward edges is not that much enough. So let's have this. You know, even you have a component here called smooth or VDB smooth. I think they both the same. I cannot, to be honest, understand the difference between both of them, but it's like when you can have a number of iteration which is different, and then convert VDB, which is you can convert them, and then you can get your polygon model. G. All right, so let's blend all together. And let's see what's happening. So why I am putting material here to just once I export it, I really want to get it more organized. So I would have here once I merge them all together, I would have my forms completely prepared. It just need time to calculate, and then I would get what is going. So if I somehow try to go more with the timeline, you're gonna have more aggregation and more let's say more growth for the line, and also gives you not extremely different alternative, but you also try to control, try to take more design decisions after. You can slice the lines, which is gonna get crazy. So I would say like that's for me for the first practice. I already shared some files here, which is it's gonna be very interesting if you somehow try to figure the process, try to write your notes, and try to get more familiar with what's actually happening. All right. For now, I would really start with another practice. So now I have the base fragmentation here, which is I'm gonna go more in depth with that. I would save the file as practice file. Okay, and then let's move for the second practice. So the next project is B2. Right, I'm gonna stop share now, and I would share something else. I think it's once you go through the files I already sent, you're gonna have it's a bit organized with the structure, which is I believe it's gonna help you a lot for understanding the sequence of Houdini, let's say, and also the idea of fracture. So before until just until until it just my file move comes again, I'm gonna show you what we from the files I already shared. You're gonna have here, I don't think we need that. You're gonna have here the same logic, which is this is the base fragmentation, okay? And then, which is this consider the base fragmentation step, which is I use it more to get more smoothness. And then I convert it somehow to volume trail. And from this volume trail, I make it as a guideline for what is here. And then I merge them together. Because actually, I really want to blend everything at the same time. And then if you go here for volume pops, that's an option I made somehow. If you want to go a bit let's say crazy with the lines, because it's somehow if you want to play a bit with like, okay, I don't like straight shapes, for example. I really want to go more unorganized with the framing. So I somehow here I add noise affected by this attribute, which is I bring it here inside, and then I multiply and I add some displacement. So once I go here, I can play a bit with this line, how it's going up and down, which is for me, it's bringing a lot of excitement to have also to play with the same techniques. So that's a point here. So if we come here at the volume trail, we're gonna have different shape, which is affected by the smoothness that's happening. So it's not organized anymore. That's the point. It's not organized anymore. That's why it could be nice, but also I am a bit okay. Once you make a fragment, you want to see it as more fragmented boxes. I believe like it should be like this. And the beauty, like how you integrate this smoothness in a way that it seems somehow you can be read it, and we're gonna talk about that with synthetic fragments, with somehow how you add volumes through that later. But it could be an option. It could be an option. So you can try it. You can play with the nodes here, and also you can give your attractor, and that's how it's going. As much time you're gonna get, you're gonna it's gonna affect all your progress. That's a point. So now, if we go back for our introduction, we're going to understand that it makes sense because it's absolutely, it's not breaks the process. That's fine. So we designed this, not designed here. And that's what makes Houdini powerful, because actually you think about process more than things. So this for me is considered things. So I don't need to design with the normal manual tools. It could be good for a start, because actually it's gonna have the conversation. But I think it's better to make everything procedural. That's the point. I'm sometimes I feel like more comfortable with doing the pace. It's okay, that's fine. But at the same time, I really encourage myself to think more and more for doing this, for doing all the process in Houdini. And also it's not about you like software more than other, but it's absolutely this software, it's considered a combination between all of other software. All right, so that's what is going on here. And let's move back for the second project we have. So here I'm going to share I would share my second project to give you a full understanding of what is going on before before going and try to, so this is our second practice, because I don't want to be run of time. I really want to share everything I have and I prepared for the lecture. So all right, let's see just some question if we have. Okay, that's great. Okay. Now we share. That's what we share. Okay. Let's press I to dive inside. Let's press to click. And then what we're gonna see here is absolutely the base fragmentation, which is we don't need to do it anymore. Okay. We don't need to do it anymore. So if we see here, this is the base fragmentation. I believe it's somehow that's a base, we're gonna use it for everything. It's somehow, I just translate the box here, which is we're gonna have it. I would say I'm really gonna go more in depth with the same logic here as well, which is we're gonna have the fragmented intersection, which is it's gonna have slice it in a way. We're gonna learn how we're doing slabs. It's a true architecture project because actually I wanna somehow get this fracture, and then it's here we somehow in a way of having this kind of integrated rocks. I imagine it like two rocks can be integrated with a very organizing sections. So that's how it looks for my side. It's, you can consider Houdini once you work as a tree. It's a tree, but and then this tree it's B-flat. And then we're gonna go more on gyroid, which is periodic surface, how it's gonna be translated in Houdini. And then we're gonna know how we build the structure. I think that's practice is I choose this one for doing it, but actually I believe it's have a lot of ideas, and also it's integrated with a way that it can be which it can be worked together. So let's have Houdini now. Let's work with this close some file. Sure. Okay. I will share this one. Share. Okay. All right. All right. So that's where we start. Okay. I need okay. I would say here, let's go for parts. Let's make it big, like it, or let's have it 10. Because actually we need to build a tower now. All right, I'm just gonna first modify with the same logic, but I really wanna get rid from some Houdini files, which we don't need. We wanna make our computers not that much heavy. There is also one pretty beautiful thing inside Houdini, which is somehow the way how the file is structured, because you're gonna find Houdini file at the end. It's something like maybe 5 megabyte or something like this, which is absolutely great. Because actually, I remember one Houdini, one Maya file, it was 2 gigabyte, which is absolutely crazy. It's like, okay. So I would say I'm gonna just change some stuff here a bit. I would press here uniform scale. I don't need anything, I just need 1. And then I would say here 1. and 1. And then let's have here 4. Then I got my tower, which is, I believe it's things is going to be fine. I somehow need to a very organized rotation. It just in 45. I don't need a notation in this direction. So I control here. So if I have this one, I'm controlling the fracture thing. It's like somehow I see a way which is it can be fractured with a very with the way that it could be organizable. So all right, I think that's it. And then I can go here with this kind of base fragmentation, but also I want to control how much point I need to delete. Okay, so I think here I don't need let's say I don't need that much point. And also I would really make the politics really a bit lower, because actually it doesn't make sense at this practice to be a bit okay. And I would say like, okay, that's all that I have. Connectivity. Now that's how it looks. And then measure. And then group selection, which is, I believe I need only, it's a bit to delete something like, okay, like the bigger parts. Like that's the only part I need to delete. Plus, that's what I want. It's not necessary to be similar for sure, like what we are doing on the practice. It's like now we investigate more on the language itself. That's what we are doing. But also, I would say let's have once I change the rotation a bit, it's gonna give me something different, which is it's totally gonna be fine. This is not for now. Like you can really try anything you really like to generate. It depends about you more. It depends about your decisions more than mine. So I would say here let's split what we have. Okay, split node is just a split, like it is split. It just split what we have to for two pieces. So now I consider this is the base tree, okay, and now I'm gonna somehow divide it for two things. So let's have node, so we can get, okay, I'm gonna divide it for two node and see what we have in both of them. So if I found here, I'm gonna have this one. I'm gonna have this one, which is that's it should be actually be divided in first selection. Okay, if I have here, if I guess from group first selection. Okay, so it somehow it's select for between 0 because I don't have any variable here, but I really want to go to see my groups, which is I should make group expression first. All right. And then let's have a group which is called slab. And what we've done before with the volume, so let's add volume bigger than channel F. All right, and then let's call it let's press here to show what we have. That's exactly what we can imagine. So before split, we need to make group, which is this group can be affected by what we have. So I should select here the group, which is now I have two channels, which is that's the way how divide it. I think it's very, very important techniques to learn how you can divide your shape for two, because actually as much deeper you can go in your design language, you can apply it, and then you can feel like it's integrated somehow. That's the point. So split is doing the beginning of the branch, the beginning of the tree. And I would say for first thing, I want to do some small fragmentation here. Like let's choose this. I would if you are not interested with the color here, you can really maybe you can turn it on, or just turn this icon, which is somehow visualize your ID, your attribute. So okay, let's go through another way of selection. I'm gonna copy and paste what I have here. That's something very important. It's like it's a way how you select. So we mentioned two things: how you split and how you select procedurally. That's the point. Because actually, if you just go and press some pieces, it's going to be broken. That's the point. And you are not working procedurally, then you can use like many other software, because actually it's the most powerful feature. You already lose it. So these two components somehow grouping, then plus, it's a way of giving that kind of conversation, which is I'm already doing some procedure things. So then I can group this, for example. Okay, and do whatever I want. Like, okay, I'm gonna have here in group, I have the option which is delete selected, and maybe I can delete non-selected. So if I copy and paste this, Control C, Control V, and if I press delete non-selected, then I'm gonna figure out two branches. So my tree is divided for four. Like I have two, so my tree is already divided for many now, which is also I can do it. I think that's a concept of how you work with, how you branch your model. Because once you see, like, you're gonna feel like it's a lot of complexity, but it's not, because actually you somehow showing what you wanna do, and then you assemble it together with a way that it can be more it can be more effective for the project. And okay, let's have here what we chose. So let's do some structure here, which is, I would say, let's fuse the point here to make sure that everything is fused. Let's fuse. All right, I'm sorry, like it should be right here. And then let's group again, and to delete someone. There's something called group delete. Also, you're gonna find practice on the files I shared. So you're gonna find some practice about group delete. If you go more in depth with that, it's gonna be really, really fine. So we need to remove one or more specified groups. That's what we have here. That's what we choose group. Okay, you can choose a name, or you can just delete star, and that's it. Right. And then tribute delete. Position, for example. So now I want to delete the attributes. I have here, once I see here, like I'm gonna have many attributes, like I want to delete. So if what if I want to delete all? I want to just say star. So these two components, I'm telling you like how you delete groups and how you delete attributes. So for example, if I have here, I'm gonna find I have many attributes here in this area, all right? And which group I have. All right, and then for here, if I just say here star, sorry, if I just say star, let's see the difference between using this and this. Stars mean delete everything. So now I only have position, which is already attributes that I cannot control because its position should be this because I already, and then if I see here, I'm going to find a new attribute, which is I already get rid of it, which is something great here, normal for the vertex. All right. Let's have polywire. All right, let's have polywire, and I would say here, we can somehow divide the form a bit because actually, if I'm going to do structure with that, so but let's do polywire. Finish the step here. Like I want my wire becomes like 002, which should be a bit different, and then let's control from here, like let's divide after this fragmentation here, let's divide the form like for more lines. So if we say divide, all right. All right, it's divided here, but it's like we have something very tricky, which is somehow if you ignore this node here is the maximum edge we have, okay, and then let's pick up polygons here, and from offset it's, for example, right, and then let's have I believe it's control more like let's have 01. Okay. I think it looks good, like even it's have here 0.5. 0.05. All right. I think it seems fine. And if I go here, like it's okay, my wire, it's like that way of how you're doing tectonics things, like let's say it's very tectonic style or same like what we were doing in Greg Lane studio in Angvanta. And so that's how I got this kind of wires. And then I would go for having my slabs. Okay, I think that's fine. Like let's have group, but actually we don't like to get lost. So you should be somehow organized in a way that gives you full understanding of the step you are doing. All right, if I come here and I would say before even doing the slab, let's do something else, which is let's have this kind of strip lines. Which like it could be the same techniques, but let's have this kind of lines here, which is can be married. So let's merge to see what is going time by time. So now let's have it how it's going. All right. Let's have the slab first. Let's have the slab first because it makes sense about what I'm doing. So I would say here for each. What actually for each doing? It's something very important. Like when I have, for example, for each loop, it's something like it repeats the process more and more. And so it helps me, like if I imagine how many components I have here, for example, I have, this is all my shape. So I'm gonna take only one, and then I'm gonna do all the process, and then it's gonna be repeated by all. But for here, I wanna say like many type of loops. I have for each number, points, for each primitives, for each connected piece, for each name parameters, like you can find like most of them they doing the same things, but this for primitives, this for points. It's very important tools, like because actually using that is allow us somehow to just doing the process for one thing, which is gonna save a lot of like it's not be about time, but it's not only about time, but it's also about makes the computer is not that much heavier. I would say for each connected piece here, I don't need connectivity. So I would plus this one here. I would go, okay. Okay. Right. And let's see, let's have here grid. And this grid could be this grade could be, for example, 10 by 10. I think that's fine. It's like it's labeled like this. It's labeled like this. Like it's labeled like this. And then let's have copy. Let's make it copy. So the idea is that we're gonna make this layering. Let's say we're gonna have grid, and then we're gonna copy the grid for like 100 times, like whatever, and then we're gonna this grid is gonna be sliced in the main format. That's how we usually create polyons with two items. So let's have here copy. All right, you have copy and you have copy and transform, which is this not. It's somehow it's copy your for sure now it's work, but what I miss now, the number and the direction. That's what I miss. Let's move it for xy 0.13. If I want to see what is happening, I would really see my geometry. Where is my geometry is? So I would say I really need to translate it down, but not the whole form. Like maybe it could be the grade. So this grade should be translated a bit down. And also the copy, it could be more, like it could be let's say it could be 15, so it can be fine. Like I just want to understand the logic of getting this. So I would say here for the copy or the grid, let's do it a bit down so it can cover this form. Like if I see the sections, the view, front, that's how it's going. This is the top, this front. So how I change my view? I change my view from here. The front, right, UV, like this is all my view. And here is if I have camera, I can do it from here. So, all right, and then it's volume. Okay. I believe like we don't really have to in this step. I would once I was doing the files, I was really trying to imagine like I want to cover all the concept of procedures. Then it's like that's why you can do it with for each, and then you can do it without, because actually you already have here you have here form. But the point like here is a pieces is not, it's not working that much, because actually I should have the number of pieces, which is I would really say I want to see what's happening here. Yeah, okay. So let's subtract. Let's here intersect this one with a grid, with a grid. See? So I want here to fix the surface. Yeah, and then I don't think I have something I need to change here. So okay. It's a bit slow. I don't know why it shouldn't be like this. It shouldn't, it's a bit slow. It takes some time to move. Like the polygon shouldn't be that much slow. And also I believe like the number of pieces is very it's a lot. I would really it's the same techniques what we have. So let's copy and paste what we have here. So to see what is really happening. Okay, it's just time. I'm using my old laptop. It's not that much powerful, but it's like the smartest that what you can deal with not a strong computer is this is the thing. Like at least let's say it's a way of behaving with what we have. So I would say here, like let's say I don't know this, like let's have here. All right. Let's revise what is here is they just intersect and from the surface. That's it. So intersect from the surface and then to take for each and just try to have this one something very important, because actually you want to have your pieces elements and then just piece attribute it's going to apply. So I would after this we have poly extrude. So we've done our slab. You can merge it. It's about materials, by the way. It's like it's really material. For me, I install somehow Redshift, but it's we planned this webinar to have a render by KeyShot at the end of that. So just press G and see how it's going. So I don't need to see the surface. I just need to see what is going up, and then I don't need any color, so it's going to be fun. Let's go for this taconic approach we have. So again, the idea here, I think like we have split here, which is, I would say, from this blast we have, once we select the biggest pieces here, I really want to take copy and paste from this one. And I would take null, and then I would name that maybe this was a structure, but and we have the slabs, and then I would say let's have here periodic surface idea. It's like, okay, so let's have here. Okay, let's have periodic surface. That's where it's going. I need to make the plus delete non-selected here to make it somehow clear. Okay, so that's a way in this part. I would ignore the middle one. So if again, I'm gonna copy and paste that, because actually you don't need for sure to repeat the process time and time. It doesn't make sense to have the notes. Like once you know how it's going, so it's really for me here, I want to plus small pieces. For let's say I want to select something. Like once you do this group expression and have it one time, I think it's like you can use it. It's like it's not about repeat the logic again and again. All right. I think it's about here. Here it's selecting everything. Not sure why it should have this kind of relation, but anyway, it's like I really want to get rid from what is here, because I believe like if you go with the design language is done, it's somehow I'm using some pieces for doing some periodic surface, so it can give this kind of two different language, let's say, which is not necessarily it's not necessarily can be portable, but it can work visually, like they can match, they can gives you this kind of intersection between two language, which is maybe it's not fitting together, but somehow you should see in your eyes that it's something matching happens. So I would say here, delete not selected, that's what I need for another experiment, which is I'm gonna do by coding after. Okay, so I would say this is my tree. Let's divide the tree before taking, like, for example, we're going to take 5-minute break, and then we're going to go more forward with having this exercise, because actually some steps it needs time, and also it's pretty important to go through all of this by yourself. Like, don't depend about the files, but just try to write it more and more, and that's how you're gonna learn the process, because as much mistakes as you're gonna do, as much understanding you're gonna have, you're gonna go to what each node actually does. And again, try to divide it as steps. That's the point. Try to draw sketches for the process you're gonna do to achieve something, and then for this process, for example, you have to do like that. So that's how it's going. Okay, so my tree now like this. This is my tree. What I achieve now, I'm gonna the tree is gonna be mirrored like that. So I would say here, and then what I'm gonna do, I'm gonna actually go more in depth with each one. So I have something here, which is this one. All right, so that's I think I have a lot for this language. So I got this, which is also gives me the slabs, but I want to use it somehow with doing what we discussed about this tectonic surfaces, which is somehow slice it with a way that it gives us this kind of section. Okay, so let's have 5-minute break, and then let's go back for another conversation to finish this practice, and then go for the third project, which is more interesting, because actually like the step here, it's through the architecture, which is you're gonna be really happy when you see, like, oh, the form is moving somehow, and then it's a change. But like we need to go more in depth with what we, after dividing the project, after dividing this fracture, what is actually happening. That's something very, very important for what we have there. I would say I'm gonna before doing the break. I just want to show you what we're gonna do for or what I means from this tectonics is like this tectonic section, which is here. Like if I just press P from this step to see, like we're gonna build it together to see what is going. Like I want to achieve something like this. I want to achieve something like that. That's what I want to achieve. Because actually these lines, which is somehow sliced in other in many directions, it gives me great feeling, which is much better than what I've seen here. But again, it's fine to integrate both. Like let's see. So if I make merge here, it's a little bit lower, and then I have it like this, and then that's it. It's either going to be like that. Since this step I consider it is very important, like let's build it together, or at least let's try to understand what is happening here. All right. Okay. Then 5-minute break, and then we will go back. Okay. See you. All right, welcome back. So I would say something very important, like you can feel like you cannot catch up, but like the idea for the webinar, I believe I want to cover, like even if I go fast, but you can somehow, once you get the recording, you can go slowly a bit, and then from this uh, 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 like you can have well understanding from each step what it can do, because actually my idea is try to cover everything even if it was faster, and because actually you cannot catch up everything and have it in 5 hours in Houdini. Like you can, if we like try to go with each node together, I think it's gonna be a bit harder to follow up, because actually sometimes I'm going a bit fast, sometimes I will be slowly in the most important points, which is, for me, I believe it's about the way how we make sure that we have uh, uh, our basic understanding of how things going, and also if it comes more interesting for you to learn that or not. That's a point. Um, I bet I would go fast a bit with what happens here. So this lines there, because actually I already turn it on to see what is happening. I will be a bit fast on this step, because actually I want to go more in depth with how you make this gyroid or periodic surface inside Houdini. So I would say I only take for each, which is divide the pieces. I'm gonna work in just one piece now, and then I'm gonna have the result, all the result I have. So what I've done here, I measure. So again, we see what is happening. So we just, if we press measure, as we tried before, and then it's just, we choose area, we measure the area, we measure elements, like it's how measure do, because actually we want to use this attribute, which is now measure creates a new attribute called area. We're going to use it later. That's fine. That's why we measure. So we usually think about what is next, because actually we have to think about what is going to happen here in attribute triangle. So we use some attributes, which is this one, very important to have it. Like if I go here, for example, I will not have the measure attribute and the area attribute, and then I create a new attribute called area, so I can go more here and then create maximum like make have this kind of two distance here for maximum volume, here minimum volume, and then integrate these two together to have let's say to have this kind of conversation between. So I would say let's do this again. Attribute promote. Okay. So what exactly attribute promote do? So it somehow it changes the attribute context, such as promoting it between points, primitive, vertices, or delete level. So it somehow let's write attribute aids, like attribute promote. All right. Let's have here primitive. Let's choose our attribute here, which is area, and then let's change it to detail, and then we're gonna have the average. Let's say minimum and change new name, and then let's see here, max font. All right. Let's copy and paste, and then let's do it here, which is we have to rechange the name, which is called minimum volume. Control 1, I add here, if I press Alt E, I add a description or understanding what's happening at this code, at this code. So it's somehow it's about two values. We have now minimum and maximum, what we already generated before. And then we create to float, which is minimum volume, as we already get that. And then we have this detailed and then minimum volume. Okay, so what if I want to know what's happening here? If I come here and press F1, okay. So I will open a new, it's gonna open something, new page, which is somehow, it's gonna explain what I mean. So let's have here F1 again. And then it's gonna have like what details. Okay, if I make it more bigger. So I press here and then I press F1. So it's gonna give me this detail. So so it somehow reads the value of a detail attribute value from the geometry. So if I went there, I'm gonna have a full understanding of what is going on and also how we write the code. So here I need, for example, the geometry, I need the attribute name and integer, which is, he tell me like ignore 0. All right. And then I repeat the second step again. And I would say area attribute, and I'm giving fit, which is a function called fit, that like if I press F1 and see what fit function do, it takes a value in one range and shift it into corresponding value in a new range. That's the point. That's why I got these two, which is minimum volume and maximum volume, which is 0 and I put 1. Then I'm splitting the line. I say here press normal to fix the normal, and then I'm getting all this line. Resample it more. To see resample, press point. And then what I'm doing, I've done all of this, which is a line to copy the grid here. Because actually the idea to make this kind of rotation for the grid, so it can slice with different direction. So if I press here, then like now that's how it's going. Okay. And then what I'm gonna do, I will group explanation. I'm gonna delete the small pieces and then poly extrude. I'm only now selecting. So here I'm just selecting the surfaces, and then I'm poly extrude it. Now that's how I go to this step. It's also depends about the rotation of the surface, like which seems it's much better than what happens here, which is only dividing the surface based on the topology. So I think that's how we can get that. Right. Next step, I would go here with what is happening for how we can get periodic surface inside the game. So the point, we need to focus about something very important. We need to focus about the resolution. We need to focus about the angle. We need to focus about the position. So that's how we're gonna go after. So let's say here I have this. I would really love to transform it a bit. Not that much. It's just point like this one's one. And then let's have volume. I want to convert it to volume, and then I'm gonna work with the volume. So what I have to do, I have to add more resolution. Let's divide it. Okay, I'm sure it's all right. So I would say 100. It's next axis. I'm not sure, and then should actually work like. Okay. If I go to properties, this initial value, let's change it to 1. Let's press G to make it a bit bigger. Okay, and then let's add volume wrangle. It seems like attribute, but it's like VW. And let's add our code. So let's have the code I add. I used ChatGPT, for example, to give me the Droid service, and it's a way, if you are not that much it's not, if you are much used to write a lot of code, you can use ChatGPT for doing that. Like if I want Control Alt key and then Control V, he gives me like this kind of consideration. I know that it's not easy to learn how to code easy, but it's like now, since AI comes live, like you can use a lot to have many interesting, and even you can go more beyond. So that's exactly the definition. So this definition somehow, it has a lot of consideration for doing Shirai. Like I just add for what I've taught to ChatGPT, like I add some key points, like for example, the resolution input, controlling the scaling, angle input, which is can modify the angle rotation. So I would consider the resolution, rotation, and also I need shift parameters to add positional variation with that. And then the output of density for generating the minimal surface. So if I just apply, accept, all right, and let's control here. Let's press this one here, which is can control the resolution, the shift. Let's have here, like for example, let's try to get 0.6. That's what is showing. And let's have here 7, for example. It's more destroyed. Okay, I would say let's have here 7 for shift, and let's make the angle, it's not that much. Let's put it like 0.3 or 0.2, and then we can get something like that, because actually I believe like now I don't need more exaggerating for my language. So let's have volume. Let's convert this. So how we convert that? It's convert volume. It's a node called convert volume. Right. Okay, I got that. I need volume. Okay, so right. And then from this to from the node here, which is also what I need to subtract. I need to, I'm sorry, I need to intersect this. Intersect. Intersect. Oh. Okay. So I would say here I need to intersect the surface. Okay, which is I believe now it's going fine. But also there are some parts which I don't need. Like there is it somehow creates some small parts, which is I believe is not the thing to show. So let's delete some parts, delete small parts, which is delete. I just saw a question about some nodes is not appeared. That's what I mentioned here for update tools. You have to get that one small SideFX lab. And because I had this experience, like there's some versions for Houdini is not working perfectly with SideFX lab. So I strongly recommend to install like at least like 20.0590, which is this is the most stable one we have until now. That's what I think. Actually you're gonna have yeah, it's like you will not have a lot of problem for installing that one. Delete small parts, which now I delete some parts which I don't need. And I believe like we can go more forward. We can now we can have our image like let's convert it to VDB, like let's VDB from Polygon, like VDB. If you really mention that, you're gonna find like the same notes, it's just happening time by time. Like it's not something new every time. Like you just doing the process a lot. Like I want to convert it as mesh, for example, here. I want to use Polygon. So I'm using VDB here, VDB from Polygon. So I would say here I need it on for let's say 0.01. It's not a lot, I know, 0.005. Okay, I would say here, let's reshape. So VDB reshape. Okay, I got it, great. So that's how it looks. So again, like the idea is that you don't have to worry. You don't have to be because actually like using Vex is the most thing that could make headache for you once you're using Houdini. Like, but as an architect, like it's really nice to have a basic understanding what is going on and how you modify your codes, and then you can use ChatGPT for getting that kind of conversation with ChatGPT, and then you can bring it here. And also you can, for example, like at shift, I told him I need shift, I need to control the angle, I need like it comes easier. So all right, so and then reshape, I needed to convert it to Polygon. So let's have here VDB from Polygon. Sorry, like convert VDB. All right. All right, I got that for, and from reshape for sure you can, if you say two, you're gonna have more thickness. It's better than the way you extrude and all of that. No, it's like you can have it with this. You can also have it from particle, like it's mean ways. So what I would say is, what if we integrate all of that together? Let's see how the result is gonna be. Okay, I don't need to see the surface. It's gonna be class, but anyway, like that's how it's going. And what if I delete this? Like if I wanna, let's know what is happening here. All right, I think it's cool. It's cool. And what we are missing the whole structure. So I would have this one, and then I would say here divide. So let's have here the same process. If I copy and paste here this one, Control C, Control V, and then if I divide it somehow, so let's say here, if I add divide, and then also I could copy and paste this node here, and then let's see what is happening. Like, okay, I don't class for sure. Like, fuse, and then I divide it, split, and polywire, and then I got my let's say I got my second structure, which is somehow it's a good means at the point of what is happening here. I would really love to add some solid, because actually is not give me so for example here if I go back in this one, once I use plus, what if I use this Control C and Control V? If I use it in another node, that it could be another language happens. So delete non-selected and then merge it again. Actually, that's the logic behind. Right, that's exactly the logic behind. It's just about the way how you integrate different language, let's say, and then it's how it's gonna be interact with the same line. And what you can use, like let's go, for example, let's have some design decision now. I would say I'm gonna do all of that without this one here. I want to do it all more take on, like I'm gonna add it here, and then I'm gonna merge it to see what is happening. Like, I just want to make sure, like, okay, all the pieces I can have this kind of slice. Yeah, and that's exactly. All right. So I'm not sure if anyone, if you guys like have question about this now before moving through the third project. Okay. All right. I would no one responding, then I would go through another project here. Or also I would let's take another 5-minute break, so the files could be downloaded perfectly. But before that, like we can say material here, and then if we go it back, you can see how you can see it much more effective, like this, like that, and then we can export it afterwards. So let's file save as, and then from node transformation, let's have this is D2, for example. I don't need the transformation one. Okay, so see you in a bit. All right, welcome back. So I would say now the most interesting part of the fragmented intersection. For the first project we have last let's say last time, we have a very interesting introduction about how we're going to split our forms. Let's say how we make this tree, how we split one node to 2 or 3, how we plus, what about VDB and this pixelization of the form, and then how we smooth it, how we convert it. It's many ideas we discussed until now, and all of that is based on just one language we have here, and that's basically the purpose of and the idea of the webinar, which is it can introduce just one fracture things and how you're gonna link it for, and you can imagine different design language after, which seems very let's say very interesting. I believe like this way of conversation with students can really create especially for architects guys, like Houdini consider a wonderful tools for us. It's basically it's incredible, and also it can make amazing results, which more than you expect. I would go before even I would not say this time we're gonna know what we're gonna do, but also I would say we're gonna learn how we fracture my VDBs this time. So I would say like that's a parallel. I will go for fracture and then I will go for growth. So let's have now it's main one and a half hour. I would strongly take like half hour in rendering, let's say, and then we have two projects which I'm gonna discuss during, let's say, 45 minutes, and then we're gonna and then for now we need half an hour to try to imagine what is going here. So same node, let's start with point from volume. Okay, I need it more dense. So the idea here, let's say we create voxels. So we want to generate points somehow, and then these points is going to be used with a way that grouping these clusters on spiritual proximity, but it's like the way before that we need to have more resolution or more points. So let's add here 0 2. I think that's enough. It's cluster. It's cluster. It's somehow divided for pieces. Like that's cluster. I wouldn't say that like it. All right. Okay. So I think that's fine. I would say let's draw box. And this box lets me the scale point tool. That's a box I have. All right. And then let's copy to points. What is variables? Why I'm doing this? That's point. So I want to give the effect of this. Let's say it's not seems stirred, but this layering and transition of the form. So I would say here copy to points, and let's see what's happening. All right. I would say the point need to be smaller, something like this. I think it's good. All right, so now I need to merge. So like let's merge what we have here with what we already have, what we already measured there. So let's see what's happening. Now I think like on the plus, we need to merge this with this. Okay, I think it looks fine. It looks fine. I would say I want to get this thing, what I'm looking for. It's like this transition. It seems for maybe not good enough, but I think like it's really nice to have, because actually I not consider this a service anymore. Like I believe like once you go here inside, you're gonna have very interesting things could happen. So I would really love to transform it a bit. Like let's transform. So even making video resolution is much easier. That's why. So here, I would say I wanna convert it first. So VDB from Polygon. Okay. I would say 1.05. Let's make the voxel size it's a bit better. 1.05. And the idea here, I want to fracture my form, but fracture the VDB. But like I want to fracture the VDB based on the fragmented. Like here I have some fragmented approach I already done there. Okay, and I really want to use that again. So I would say Control C, Control V, and then I can bring it here. And I would say VDB fracture. It's a component that break apart the geometry to represent VDB, to represent it as a VDB volume, but somehow it separates this to smaller fractured pieces. So I would say here, let's have, this is the base form I have. And then before doing this, I would have, okay, maybe after transformation, let's turn this on. And I believe we need to scale, this up. Like let's have here too, even still smaller. And so let's have, yeah, let's have it bigger. Like, sorry, let's have it bigger. Let's do it like this, for example. I think it's okay. Like, so let's have this structure based on this fragmented, and now we can see what happens here. All right, but to visualize it better, or let's go more on smooth SDF, like VDB smooth SDF. VDB smooth SDF. All right. And then I'm gonna convert my VDB. I would, if you want to see the fracture here, and then I want to like this convert VDB first. All right. I want that to polygon. Now that's how it's looking for my first imagination about what is happening. I really love this part here, which is somehow it's create not that much dense image. All right. For now, I think it's fine that we convert, we got the mesh, and also I believe like this kind of things that it's bringing some interesting thing happens for the surface. So what if we delete some parts? Because actually, I believe like there's some part, for example, like this part, if it's if it's deleted, it's gonna be much better for the form. Like even let's delete more. Yeah, I think it's fine. Like I don't need this small piece that somehow is not looking like that much interesting to handle that. I would say now I wanna give some noise, but only for the surface. So let's group. Let's have group. All right. And then I would name that face. But I'm gonna repeat the same process again. And I want to group by normal. So we didn't discuss what group node. It's one of the most important nodes inside Houdini. It's something how you group the surface. Maybe you can group it by normal, you can group it by region, for example. If I press here, and then I have this kind of box, and then it can be grouped somehow with based on this box. Like if I grow it like this, it can be grouped, and then I can just select these pieces and start work after. But here I want something else. I'm going to do some grouping by normal, which is, for me, I want to just select the surface now. So I would say I need only 14, that like split points. I want this consider for my points. I want to select the points. Yeah, that's how it comes. It's great. Okay. And then I want to select the other side, which is Control C, Control V. I want to say like the direction can be different. Like I would 0, that could be 1. Or let's say here is this 1 and this is 0. Like, okay, I think like this one is fine. And what about that one, which is 0, 0, so it's 1. And let's name face as well. Okay, let's name face, but I want to make it to union. So it's here like that point. Like I want my copies becomes both at the same time. Like here, for example, that's what I'm saying. 1, 2. What if I? Yeah, I think it looks fine. It looks nice. Like if even I say 1, 1 and 1, it's gonna be fine. So let's merge. This is how it's gonna merge both. So now I have these 2 selections, which is now by this one. It's instead just do 2 groups and merge them. We can say distance along geometry, this node here, which is somehow to remove disconnected geometry pieces. Okay, let's do that. And for the code, for the code start point, let's add face. That's what I want. Okay. Here is case from group. That's fine. I would say here, I need mask, I need pointer. No, not now. So, okay, the surface, I need mask. And then let's make the radius, it's a bit lower, 5. And let's control what is here. So if I go with this down, or even it's come here, like, but it's better to control the nodes. I know that it's somehow it needs to be visualized, but if the thing is going a bit heavy, you can ignore that. Like it's just about how you're gonna be comfortable based on your computer for sure. I would add noise. by something called mountain. Okay, so I think like last time we start from the hardest thing. So we start how we're doing noise based on VOPs. And now like Houdini give us this node, which is called mountain. It's really have a lot. It's like has it can do for example, we have many types of noise here. We can go more and more. But the point here, I want to add I want to just add here mask, and I want to go with what I've done basically with my attribute. So let's go through mountain, and then in state constant, let's use attribute. Okay, I think everything is fine, but let's have here, let's make it a bit lower. And let's see what is happening. So that's exactly what happens here. So I made the noise, but only on this surface. It gives me not that much effect, but I really want to see it not that much exaggerated. So it somehow gives me something interesting happens here and here. Yeah. Let's connect these by this add connectivity. Actually, I want to connect points here. That's fine. And I think like I need to connect the parameters. Control C, Control V, and then let's choose here primitive. It's really beautiful to understand what each node is doing. I also somehow I attached a PDF which is define what each node doing, which is going to be really interesting. So I would love to fracture it more and more. And what if we but before that, let's organize it a bit. I think like let's have this as group. Okay, this fragmentation. I think like until here, let's see what is happening. Yeah, let's have this as group from here to here. It's this until that one. Let's have it as group. Okay, and then let's have this copy Control C, Control V. And then let's fracture it more. Let's delete the same step. So we want all of that. So what we only need, we need to just change like just change here the rotation, like just change anything so we can have another another conversation happens through your fracture. Let's see. Yeah, let's fracture it more. Now it's going more. Exactly. Like if we see the different step here I had, but also I want to connect this connectivity, it's the same fashion. Like it takes some time because actually now you work with a very, very intense geometry. All right. I would say something like for now, I would really see what is happening, but it's really nice to try to. I'm gonna copy paste the steps we are missing to get this kind of fragmentation. Same like the poster for the workshop. So what I have here, I would say Control V. Like we're gonna have the missing things from the code. I don't wanna go more with that, but I'm gonna also explain what is happening. Yeah. So what happens here? Again, we also group the face, which is I believe we already have this step. We don't need it. So again, connectivity. Okay, so what exactly happens here? If I just gonna take one piece only, but it's unfortunately it's gonna be heavy. It's gonna be really heavy. Like, but let's do something. Let's plus, because actually this is the way how it grows. Let's plus here. Okay, and let's take something like this. Okay, and then it's selected, but I wanna delete not selected. That's what I'm gonna do. So this could consider like my form. All right, and then I'm gonna take it and go more forward. So here I'm doing just take one piece, which is already I already have it now, and I'm doing some groups. I just select faces, okay, and then extrude it a bit like that, so it can gives more variation. But I think I really wanna do something before. Let's say here, I would really say for each, like I want to extrude the pieces more. Like the step I already have it. Like for example, like I would say connectivity. I would really plug it here. Okay. Because actually now it's the way how it's extruded is not the best. So firstly, let's just see the file we have here, so we can go. Or I'm going to share the file again. Stop share. I'm going to share. Okay. Okay. What we have here? All right. So I think we achieve until this step in our we fracture it more. We just take piece and then fracture it more. And we talk for each, since we have to. Okay. And then with the same way we've done, we select the group here in Z direction, and this is on the other side, and we fix the normal, and then we add some code. So this code means like we somehow try to extrude based on the normal direction, let's say, and we somehow add some channels, which is we have here the iteration C, and then we just make this fit, which is what we discussed what it means before. So if we have here F1, you're gonna have like it's usually playing between two channels. Yeah, like that's how it means. So we can extrude, poly extrude. That's what happens. And also you can control the extrude here, which is I think one is enough. All right. Then it's gonna be repeat for all. Connectivity again, and then we just have one piece. Unfortunately, here it's like you said catch piece. All right, I would go more. It's not showing what is actually doing, but like we can see which growth happens with this one, and that's what I want to achieve. I want to have this kind of growth, which is somehow it's blended. It's inspired from ecology, let's say, and then this how you blend two stones or together somehow. All right, then I have here VDB analyze, and then I add some. I go through volume VOPs, which is you can discover here what is happening. I add some noise, and then I want to play it with a curvature. So I made here two attributes, which is already there, and then I blend them and multiply and I bind export the attribute again. Which is, yeah, that's how it's gonna look. It's like this kind of fracture thing. If you have very powerful computer, you can do this step for all, for sure. But unfortunately, my laptop is really hard to manage what happens here, because it needs a lot of yeah, even it's gonna take a lot of time for producing this kind of growth. I would say I don't need to show more. Like, I'm just satisfied to see what is happening here. And then we usually merge all together. All right, it's gonna take a bit time to be showing. We have now 1 hour, and I think we need to somehow discuss other ideas, but this time we are not gonna go step by step. I would go fastly with the two remains files, so we can go more in depth with what happened. All right. I think, like, let's take a just 3-minute break so until the file open, and then we're gonna be back. All right, we back. Okay, before moving through the next one, we want to have here just to get a log for what is happening. And actually, based on your time and your computer, you can try to generate more pieces like this. It's going to be more interesting. So let's have file, because actually I want to export it. Now let's have no, like, now is the end of this conversation with this geometry. Anyway, like we can save the geometry from here, save geometry, it's a way. And then we can, I need it as object. Let's save it for sure. Okay. Here, let's say object. And then it's like for, this is for, let's say art3, and then save. Okay. This is how we save our geometry. Okay, so now we got this pieces, which is really interesting. I'm gonna open the next file. Which is actually, it's the same logic. It's the same logic. Like I believe I made them all the same conversation, same way of conversation. So you can learn how you from this structure you can achieve something very interesting. If you are interested with ecology and how that related to architecture, you can go through that and see how like how these behaviors happen, and then go more like that. So I'm waiting now to computer, like let's see what's going. All right. Okay. Okay, share again. Ah, it comes. Good. All right, so I want to go fast a bit with what is happening here. So basically, it's the same logic again. Boolean fracture, and then we are not gonna have like not for this logic, like, but let's say that's what happens here, like the same logic, the same fracture logic, and then we plus some pieces which we don't need. Even if we didn't plus, like I think it's fine. So let's use null, and then connectivity, and I measure the volume, and I use time shift to make it a bit free. So I don't want to move it anymore. Like if you want to use time shift, it means like you just freeze the frames in on 7. That's the point here. So you don't need to use this kind of moving habits, because actually once you move the timeline, the shape, it's going to be changed. So it's somehow we got this one, this part, which is we go more basically on advanced. So here, what we talk about close, it somehow it give us this kind of let's say of expanded somehow. So I made these two sphere, which is I merged them together, and then based on this form, let's say, yeah, let's do it like this from, and based on this form, I would say, let's see how they move. So if you change the timeline, you're gonna see here how they be expanded, which is something very cool. It's like it gives a lot where the space can have where the space can be expanded. So that's how it's turned on here. I stopped until 7. All right. And then what I've done, I used the same logic. I just make here, let's say let's move to perspective view. I made this volume, and then I applied the same techniques with this periodic surface. What we've done, what we've done previously, and I boolean post together. So I boolean this growth here with habitat, which is found here. So that's how it looks. And then I boolean post, and also I delete small parts. So it's boolean, and then I give it some thickness from VDB from Polygon. Like I just copy and paste this part because actually we already have it on the way of how we're doing Droid, and then I combine post together. So now it looks like this. Okay. The next thing happening here is how I add typology for the service, because actually the service is not look interesting anymore. And also I wanna think about some other language, because once we here, let's say, merge it together and reshape it somehow like that. Okay, I feel like this piece looks very interesting with this part, and resample it. All right, smooth a bit. Okay, I would get rid from what I've shown here. I don't need anymore. And let's see what happens. And then I made the same techniques to blend it again and again. I converted somehow, and I subdivided. So I had more subdivision. Why I added more subdivision? Because I'm gonna here play with the typology. So I add here nodes called point VOC or attribute VOC. So I want to add some noise, and then want to displace this noise. That's a point. So I use that kind of noise, which is parallel noise. But something very important here, which is the displacement comes through this. The displacement already only affects the normal. So let's see what happens. So like this. Right. I want to get rid from what is shown here, like these points, which is when I do it. But I think like this differentiation between two topologies looks very, very interesting. Like the noise adds big value for what is coming. And all right, let's say here BDB campaign, because now I want to campaign this layer here I had through what I have here, and then I'm gonna blend them together like that. If you see why it's doing that, actually it creates a very inspiring space here. It's something like more it's it could consider it fluid. It's not just like fluid, yes, but also once you feel like you have this kind of desert or stones, and then you have this space which is inside, which is somehow it's a bit organic forms, but and integrated with straightforward surface. I reshape a bit the form. Houdini notes it needs let's say to get it to practice more and write it more by yourself. So and then BDB from Polygon, I converted because until now it's not Polygon. Once you convert it, it somehow the computer takes time for the process to be. All right. So we have now our second practice, which is actually have this language here. I think like it's a form with a red one, which is somehow it creates this kind of you can add slabs, you can add many things you have. For example, here I I converted a bit, and then I just took this shape, and then I want to copy some buttons. So it's somehow I took this one, I just split it, and I select that, and here from this service I made some points, which is we already discussed what points from volume do, and then we group, and then we copy that point. All right. So what this part do, if we remember what we had, this kind of sequence, for example, if we convert this shape, just this shape, if we copy and paste this part, and then somehow see what happens here. So we're gonna have another wave conversation, which is very, very interesting. So I don't want to share it. Let's just close this, and then, which is now you have this layer which is considered it's not, let's say it's not the same, but it's also have this kind of topology. So once you integrate it together, this stuff on this layer on the surface happens here, you're gonna have like this kind of more smoothness surface with let's say the stairs. I call it here, like that's how it's gonna look. Which is, I believe we need that. We need somehow to break this kind of smoothness in a way that it give us like that give us different conversation between these two languages. Yeah, like if you look here, it's maybe more interesting. All right. So afterward, I transform the service to be like this. And then I convert all for one PDB. That's the first. That is the first file we have. It's the same language with another way of conversation, and it gave us something. I would be really happy to see how you're gonna behave with this script now, and how you're gonna build your own script, and let's say what you're gonna bring different between the languages of fracture. Yeah, that's what we showing here, and then I will share the other file. Okay. Okay. All right. Let's open the other file, which is number 5. Over. Okay. I would say the last practice, which is it was the last post I shared yesterday. It's something how you interact this with this synthetic simulation in a way, like, but I would say how something could interact with these services. So let's try something here, which is let's share my screen. Now it's going fine. All right. I will not go in depth with we are not gonna build it again, since we are not gonna go out of time, but I would say here the file we already saved, let's bring that R3. All right, this one here we have it. All right. I'm going to transform it a bit. And this is my out collider. I would go back and then let's see what we really have. All right, so now this is the file I got, and I don't want to show my file, but I want to go more in depth here. Okay, so this is the file I have. All right. The idea here, I'm gonna use for simulation to interact with the solid geometry I have. So I made surface, let's press G. I copy the spheres to I have now 3 spheres, and I transform it somehow with on y-axis, and then I made another copy in these 2 directions, and I transform them again, and then I merge them both with this interaction. All right, so there is a node called biosource, which is somehow convert these spheres to points, which these points, it can be translated after to this kind of volume. All right, and what we're gonna do, we're gonna actually play with this point. So if we somehow drag, like that's how it's let's say how is the fault gonna be pushed. And if we consider like as a trail, that's how it's going to be pushed. So I consider this point is pushed with this wave. I think that's something very, very interesting, because actually we can have this simulation with a way that it can be integrated. That so another node called import field here, which is we have here two different source of I could consider it fire or something like that. So I have this one, which is also we can push these points, and it's being merged somehow. So I have these two. And then once you go here, you're gonna see what is happening. All right, you're gonna see what's happening here. We could convert that to volume trail. So what we figure out like this, it could be led by this kind of interaction, and it give us something like that. Right, once we move with the timeline, we're gonna have what is shown here. So let's see what is the relation between our form and what is there. I would strongly go for make the trail, for example, here. Where is our trail? Is there? And then let's transform this one. Transform. Or what we can do, we can go, we can just go here. This is just on. And then if we go here inside, we have items here that show other objects, which is something very important to see what is the relation between your object and other nodes. So I would say transform. I'm gonna do it manually this time. Let's say set view front. Okay, I want this interacting this way. All right, and then set view top. Okay, I think like I really need to be do it manually a bit. It's like how it's gonna be. And then I would transform it to somehow 0.7. And then let's see how it's going to be interact with this Fox simulation. I would say like, I think 0.5 could be enough. Okay. So now I'm pressing enter to be inside, and then I'm gonna press camera to be outside, and then press G. And then let's go back. For sure we can repeat that. It's based on your geometry. I played live. So, okay. So now we can do it again. We can repeat it. Okay. So now this is our shape. This is how it looks. I'm converting this one to polygon. So I want to array what is happening here. So I don't want to have this kind of intersection on the inner space, because I would say like the inner space could have some slabs in a way that it could be habited. And this one here with this kind of growth, it could be, for example, as a landscape growth that happens for to interact with this shape. I'm resampling with that one, and then I combine both. But here combine, you have to choose difference, because actually you don't want to do this anymore. Like if I have that one here, that's how it looks. This one here, that's how it looks. Yeah. Yeah, I think it's great. So let's have okay, let's smooth. Let's have this smooth. We smooth the BDB, we reshape it a bit, we convert our BDB. I took here the line, the volume trail to polywire it, because actually I feel like to integrate the structure with the service, it's something very interesting. Like here, for example, once we can see how is the structure as another layer, it's integrated in a way with this form. All right. What about when we as a here to, for sure we slide it somehow to have this kind of slabs like this. So what I've done here, I add some slabs, and then I merge all together. So that's how it comes. It maybe looks like it maybe looks like something in the landscape, and something it's growth, and then it integrated with the natural somehow. Yeah, I do believe it's to our language. So this is for let's say the last experiment we have, and then we're gonna use some stuff to learn KeyShot. I think we can take like let's say 7-minute break, and then we can go to KeyShot and try to learn how we export, and then how we render. Right, okay. All right, welcome back. So, so we're gonna learn here. Let's say we're gonna export this shape now, and then we're gonna open KeyShot so we can render that. All right, so I will save geometry here. It's like this is, we can save it with many ways, but for me, like I would say copy, okay, and then I write here, okay, copy. Then let's say here, this is P1. So then let's have, this is our surface, which is something fine, and then accept. Okay, so now we're gonna have introduction for KeyShot, how it's going. Actually, KeyShot, it's a very, very interesting product design render. Somehow it gave us a way of showing our models. That's how I can translate KeyShot. It's very beautiful. You can do a lot of interesting renders, but most of my renders in KeyShot, and then I want to see somehow the beauty of the form, how it's going without. You can add more dramatic things, but that's how I say. I really love to have this kind of model render because actually it gives me, let's say, a clear imagination how my form is gonna be. So in KeyShot, you have these things here, which is here you have, for example, you have this menu, which is you have many modes of render. For example, you have, usually we choose CPU. You can depend about CPU render, which is comes more faster. And you have here material, which is really material that KeyShot give us for like give it for our shape so we can experiment easy. So we have colors, if you want to add colors, texture, environment, really environment, we can try with that later. And also the idea, you can also add some new material or new texture. For example, you have here, if you want to add some HDRI, it's open HDRI. And if you have something customized for you, you can, if you have your own HDRI, for example, you can upload it from here. Yeah, you can upload from here if you have something special. Like, for example, I already download my own HDRI. How we import our model. So file, import. And then we have this one here in the desktop, and then it's P1, and then import. All right, so that's how it looks now. So now we discuss what this menu mean, and let's move here, which is we have here our scene. It's going to be shown. And also we have here our material, which is already imported. I only have it as one material. We have here camera, which is you can add how many cameras you want. Like, for example, I took this view, I have it like that. Okay, we can have another view. And also, for example, like we can go more in depth with what is happening and to have the iPhone. So for the environment, we can here change the environment, but before, let's control the image size, which is, I believe, like for now we need landscape one, which is this one. Could be much better. So if I double click, he's gonna move me directly to the material I have. I can control the color of the material. For example, I would say I need white, like that. So And then we can, if I'm not satisfied about that, I can have some customized HDRI, and also I can hide the background, or I can do my own. So how you do many HDRI at the same time. So if I add new, like here is not duplicate. If I just try to imagine like, okay, I don't need this HDRI. I need something else. So I would say here, I need only color. I'm gonna set the color black. I'm gonna set my own light, which is like this. Okay. And then let's have let's just control the radius of the light like that. And then let's have it, it's a follow, and then control the radius of it. Okay, so for the background, I would say if you select here's background, I could have it as color. Okay. I think that's fine. But if I go for the setting here, I could change it to the color, and then I want to make it all black. So I can only go more in depth with the form. Let's add more interesting thing. Let's have here another light. And this time, let's change it to blend. So we're gonna blend the color for the base one. Let's add another one, and let's change the color of the. Okay, maybe it could be red, it could be blue a bit, like that. It can be also fine. And also we can go more in depth with the light here, which is gonna be more interesting. Until now, I didn't change anything about materiality. I didn't do any material. I just want a configuration. What is the light gonna happen? Gonna give me and what result is gonna be bring by light. So okay, let's say here another camera, and then let's go. We can for sure we can try mini HDRI. If you moved here, for example, you can try this one. Try what the job like HDRI gives different kind of interesting like you choose it, you can choose this, and this is between two colors. You can for sure change the color. So let's have this one here, which is I believe we need also to change the ground. So to change the ground, I would say like this could be fine. So let's go for hours, which is we need to emphasize the light more. Okay. I would say like let's do it like that. Okay, you can change for sure like which you need. You can make the radius more. So what about materiality? We can choose many type of material. For me here, I upload from here, from the cloud. One of the best materials, I believe, like it's very interesting material. Because somehow this material, it gives me, let's say the edges, and also it gives me more variation of what is happening. So if I press this, if I press here, and then see how I can change, for example, I can use curvature, for example, here to see what is the curvature, what's going, how's my form is going. This, I believe it's very, very interesting. Also, I don't need to use translucent because actually here I can use translucent form, which is also fine. So I would go to paint normally. And then you can go more forward with just the color. Let's change the color a bit. And if you need to change, to have it more reflected, you can go here and change the reflection. If I turn on CPU here, I'm gonna get it more fast. That's one, more fast and more clear. So you can try a lot of material as you like. You can go here also. You can Change the color a bit. It's okay. It's based in your eye. And also they have something very interesting here, which is I think control, which is somehow explained where is the most intense pieces. I would say we can really use this one. I believe it's more for me it makes sense more with this organic form and this organic growth that happen. And also with the lighting even it's more better. Like you can control which kind of light, like this gradient of light is something very important. Like once we compare about our two HDRI, we're gonna find I think these ones need more contrast. If you wanna believe like, okay, I wanna integrate it with the side, I wanna integrate it with, I don't know, it's based on your it's based on your eye, let's say. It's based on your what you imagine, because actually everyone has his own imagination about what you're going to do. Because for me, I believe like, okay, this angle could be it's a better angle because actually it's showing a lot of gradient, a lot of level, and maybe you have something different. You can you for example you show let's say you want to show like, okay, I want to for example like have more in-depth shot, like and also you can use you can really do more. So I believe that's for what we got for now about the fracture, about how we move this language um, for other translation, let's say, and then how we can export it from Houdini and how we render it. I would say if anyone have any question about anything during the talk, I really prefer to have 20 minutes. If anyone have some questions, and it's also revised the comments. I'm sorry, like I was really out of the conversation that happens. And thank you, Walter, that you respond a lot of this was a lot of question. Yeah. So okay, guys, is anyone have any question? If you still there, if you hear me well. Yeah.
Thank you, Assem.
Yeah, thank you, Mike. Thank you. I would say something that it's Houdini. At the end, it's very, very interesting tool. Like I learned a lot before Houdini, but I remember I stopped at this point and I told myself like it's really reserved the time that you can spend to go more in depth with the software. And also as an architect, it's very, very powerful tools. And it's like you don't have um, any barriers to think, to move forward. And also, I have this kind of collaboration between scientists here in Angevin, and they wanna convert what happens in natural and this ecology. And I found Houdini is a very, very nice tool for that. Yes, that's it.
Yeah. Well, yeah, thank you so much. And there's nothing else you want to show, right? This is
Yeah.
yeah. Cool.
Yeah.
Yeah. So thank you everyone for attending and those that stayed the entire time as well. And you'll yeah, and so after this, when it's done, you'll get an email and to watch the recording and files and all that. Thank you, Assem, for your time on this weekend.
Thank you.
Yeah. So with that, I guess we can end it.
Yeah. All right.
Thank you.
Thank you,
Thank you,
guys.
everybody.
And thank you, Michael. Yeah,
And
thanks.
if you're in the webinar tomorrow, anyone, we'll see you then tomorrow.
Yeah.
Thank you.
Right. See you guys. See you, Mike.
See ya.
Goodbye.